Thank you, Mr. Sullivan. I am now going to introduce you to what is called the transitive property of parallelism. This theorem says if two lines are parallel to the same line, then they are parallel to each other. So let's take a look at our figure here. We have line A here and line B here. And you will notice that by these markings, we know that line A is parallel to line B. We also have line C down here. And you'll notice that the markings on the right over here, that line B is parallel to line C. And our theorem states that if line A is parallel to line B and line B is parallel to line C, then line A has to be parallel to line C. Can you see how this is the transitive property? We have three different lines here, and they all end up being parallel to each other. Now, to prove this, we are going to, of course, introduce a transversal. I'm not going to actually do the proof, but I'm just going to walk you through it. You will notice that because line A is parallel to line B, that the corresponding angles are congruent. Also, because line B is parallel to line C, that the corresponding angles are congruent. Oh, wait a minute. That means that these corresponding angles are congruent by the transitive property, and then by the converse of the corresponding angles postulate. The two lines are parallel. Our next theorem is the two lines perpendicular to the same line theorem. That's a long name, but once again, these names are to help you understand what the hypothesis is, what you need in order to use it. And this theorem states that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. I want to point out that this statement right here, in a plane, is very important, because if you're not in a plane, these two lines may be skew, and then they wouldn't be parallel. So it has to be within a plane. Here in our figure, once again, we have lines A and B, and we also have line C here. And we know that C is perpendicular to A. Remember our perpendicular symbol there. And we also know that C is perpendicular to B. And our theorem states that if C is perpendicular to A and C is perpendicular to B, then A has to be parallel to B. Now this one is much easier to prove than the last one. And once again, I'll just quickly walk you through it. Since C is perpendicular to lines A and B, that means that these angles here are right angles. And we had a theorem once upon a time ago that said all right angles are congruent. So these two angles are congruent. Well, these two angles also happen to be corresponding angles. Since the corresponding angles are congruent, that means that the lines are parallel by the converse of the corresponding angles postulate. Do you see how quick and easy that one is?